In this video, we're looking at rotations. We're going to be working on pages 12 to 15 in the Algebra 1 Summer Math Packet. Okay. Rotations is the act of rotating a figure or a point. They can either be either clockwise or counterclockwise. So a clockwise rotation is going to be going that way. A counterclockwise rotation would be going this way. A clockwise rotation is considered negative. A counterclockwise rotation is positive. The way I like to remember that is having to do with the quadrants of the coordinate plane, that we have quadrant 1, 2, 3, and 4. And if you rotate from quadrant 1 counterclockwise, your quadrants are increasing. It's positive. So that's how I think about that. Here we're going to start just by graphing triangle ABC. So go ahead, you can pause the video, graph it, and then we'll have triangle ABC graphed. Okay. There we go. We've got our pre-image triangle ABC graphed. Now we are going to graph the image A prime, B prime, C prime after some rotation has happened. So go ahead, graph triangle A prime, B prime, C prime. Now that we have the image graphed, A prime, B prime, C prime, we want to look at how the triangle has been rotated. It's been rotated one quadrant, would account for a rotation of 90 degrees. It's rotated from quadrant 1 to quadrant 2 in a counterclockwise direction. So we could note that as a rotation. Rotations, we use capital letters of positive 90 degrees. Okay. Now we want to look at what's the relationship between the coordinates in part A to part B. So maybe that's just looking at one ordered pair, sort of what happens from A to A prime. So I might notice that the X coordinate now becomes the Y coordinate, and the Y coordinate now becomes the X coordinate, but it's negated. And then let's check for B. Does that hold true? Yep. Also for C. Okay. So to show that in coordinate notation, right, we said that the X coordinate becomes the Y coordinate, and that the Y coordinate becomes the X coordinate, but negated. So we'd show that as XY goes to negative YX. So that's our rule for a 90-degree rotation. And we can use that rule when being asked just to rotate individual points or figures. So I'm just going to use the idea that XY goes to negative YX. So a rotation of 90 degrees, that means the Y is going to come up and it's going to be negated, and the X is going to go to the Y coordinate, just like that. Easy peasy. So go ahead, try the rest. So here you can check your work, right? Everything just going XY to negative YX, and that last one just kind of checking with us to see if we understood the rule. Okay, let's try another rotation here. We're going to graph triangles CDE to start our pre-image. Go ahead, graph. All right, so we've got our pre-image CDE. Now we can graph our image C prime, D prime, E prime. And now we've got our image graph C prime, D prime, and E prime. How has the triangle been rotated? Well, it's rotated two quadrants. It's been rotated 180 degrees. In which direction has it been rotated? Honestly, either, right? You can get there going clockwise or counterclockwise. Okay. So when we talk about a rotation of 180 degrees, it doesn't matter if we talk about it positive or negative, because either way, it's going to wind up in the same spot, in the same location. So now let's look at our coordinates. So what happens in our coordinates? And I think this one's a little easier to see, right? Because we don't have a switch of X and Y. All we have is a change in signs. So as we rotate 180 degrees, and again, that's either direction, XY is going to go to negative X, negative Y. And if I'm rotating an individual point down here, all I'm doing is just changing those signs, right, of each of the coordinates, and that'll give me the location of the image after a rotation of 180 degrees, right? And obviously 0, you can't change the sign, it just says stays 0. So this point would have been on the y-axis below the x-axis, rotate 180 degrees, it's on the y-axis above the x-axis. Okay. And like we talked about in our reflections, it's these rules we're going to use. So we're going to be really just focusing on using these rules of our rotations, that xy goes to negative x, negative y, when we rotate 180 degrees, and when we rotate 90 degrees positive counterclockwise, that xy goes to negative yx. And let's look at how we can use that to rotate a given triangle. So we're asked to rotate triangle ART 180 degrees and plot the vertices on the coordinate plane below. For me, looking at this problem, I'd first want to find all those coordinates of our pre-image. So I can see A is negative 5, 5, R is negative 9, 1, and T is negative 4, 2. And then I can find the image points using our rule. We're asked to rotate 180 degrees, negative, which is the same as positive. So that's just going to be negative x, negative y. So A prime will be 5, negative 5. R prime will be 9, negative 1. T prime will be 4, negative 2. And then I'm ready to plot. And there we have our image. A prime, R prime, T prime. We can also use our rules to help us with just rotating points. What are the coordinates of the point negative 7, 6 after a rotation of 90 degrees followed by a reflection over the line y equals x? Ooh, so we're getting to do 2 here. That's good. All right, so first we're doing a rotation of 90 degrees. So I'm going to use that rule. Xy goes to negative yx. So that means that negative 7, 6 is going to become negative 6, negative 7. That's after the rotation, right? And now we've got to use the rule for the line y equals x. And maybe I flip back in my booklet if I don't remember it, but that rule y equals x, that's where xy is going to go to yx, right? And now we're using this new ordered pair, negative 6, negative 7, and we're going to reflect it over the line y equals x using our rule. That's going to give us negative 7, negative 6 as our final answer. Cool. All right. If the coordinates of point P are negative 3, 4, and the coordinates of point P prime are 3, negative 4, how many degrees has the point been rotated? So I want to notice negative 3, 4, 3, negative 4, both the signs have changed. So that must have been a rotation of 180 degrees because I can see how that rule would result in those coordinates.